Hello everyone. In this lecture, I'll be discussing about timing diagram of 8085 microprocessor. So before going into the detail of this topic, I'll be discussing few terms. So starting with instruction cycle. So what is instruction cycle? The necessary steps that a CPU carries out to fetch an instruction and necessary data from the memory and to execute it constitutes an instruction cycle. That is, time taken to execute one instruction is instruction cycle. So let's take an example. So MVIB05H, I have already told you in my previous lecture also that MVIB comma data, you can write anything in place of 05, you can write 06, any data. So MVIB comma data is an instruction of 8085 microprocessor. So the necessary steps that a microprocessor will take to execute this instruction or any instruction of 8085 microprocessor is known as instruction cycle. So what happens, as we all know that MVIB05H is a 2-byte instruction. So first byte is for the opcode and the second byte tells about any hexadecimal data, 1-byte data or 2-byte data, whatever data that is mentioned along with the instruction. If it is 1-byte data mentioned in the instruction, then it is a 2-byte instruction. If 2 bytes hexadecimal data mentioned in the instruction, then it is a 3-byte instruction. So here, since 1-byte data is mentioned along with the instruction, so this whole instruction is of 2 bytes. So when this instruction will get stored in the memory, it will occupy 2 bytes. I have already told you that any memory that is associated with 8085 microprocessor, it will have memory locations and each memory location will be of 1 byte. It can store only 1 byte data, whereas the address of the memory locations are of 16 bits. So when this instruction will get stored, it will occupy 2 bytes. 06 and 05. 06 represents the opcode of the data, how this instruction will get stored in the memory. First, the opcode of the instruction will get stored in the memory, and the second memory location and the successive memory location will be occupied by any hexadecimal data that is mentioned in the instruction. So randomly I have given the addresses like C000. So it can be anything, any address within the range of the memory, address range of the memory. Now, so how this instruction cycle takes place? So basically this instruction cycle is made up of 2 cycles, fetch cycle and execute cycle. So let's talk about what is fetch cycle. In fetch cycle, the microprocessor fetches opcode, that is machine code of an instruction. Means here the opcode is 06H. Fine. In fetch cycle, the microprocessor fetches opcode from the memory. So the necessary steps which are carried out to fetch an opcode from the memory constitutes a fetch cycle. Or in simple terms, I can say the necessary steps that a microprocessor carries out to take this data, to take the opcode, to take any opcode of any instruction from the memory is known as fetch cycle. So fetch cycle includes up to that point only where the opcode reaches the microprocessor. Once it reaches the microprocessor, this opcode reaches the microprocessor, there the fetch cycle gets completed and the execute cycle gets started. Fine, again I am repeating, fetch cycle includes those steps which the microprocessor takes while taking the data from the memory to itself. So when this opcode reaches the microprocessor, when it gets stored in the instruction register, the moment it gets stored in the instruction register of microprocessor, the fetch cycle gets completed. Now the next cycle, that is execute cycle, gets started. So the entire operation of fetching an opcode takes 3 clock cycles. So this entire operation, that is taking the data from the memory to the microprocessor, takes 3 clock cycles. So I'll be telling more in detail about the clock cycles, T states, machine cycles in my later slides. So what happens when if the memory which is associated with the microprocessor, it is slow, it may take more time. So in case of a slow memory, the microprocessor has to wait till the memory sends the opcode. The clock cycle for which the microprocessor wait is called wait cycle. So most of the microprocessors have been designed to introduce wait cycles to cope with slow memories. So this was all about fetch cycle. So the next cycle, that is execute cycle. So once the opcode has reached the instruction register of the microprocessor, there the fetch cycle gets implemented and the execute cycle gets started. So in the execute cycle, what happens? The decoding of the instruction, the decoding of the opcode occurs, and after decoding, the execution of the instruction occurs. So execute cycle includes decoding as well as execution part. Or more clearly, what happens? The necessary steps which are carried out to get data, if any, from the memory and to perform the specific operations specified in an instruction constitute an execute cycle. Or the time required to fetch as I've already told you that the time required to fetch an opcode is a fixed slot of time, that is 3 clock cycles. Now I've told you, while the time required to execute an instruction is variable, which depends on the instruction to be executed. So if the operand is in the general purpose register, let's take this example, the MOVAB. What this instruction does, it stores the content of register B to register A. So it is also an instruction of 8085 microprocessor, as I have told you in my previous slides also. So what happens? This is a 1 byte instruction. How 1 byte instruction? Because it has only the opcode and no hexadecimal number is mentioned, or hexadecimal data is mentioned along with this instruction. So this instruction is of only 1 byte. So when you're going to store this instruction in the memory, it will occupy only one memory location, that is 1 byte only. So in this type of instructions, what happens? In fetch cycle, microprocessor will fetch the opcode 78 from the memory and store it in the instruction register of its architecture. So the fetch cycle gets completed. Now from the instruction register, it will go to the decoder, it will get decoded, and then microprocessor will, after decoding the instruction, microprocessor will get to know what operation it has to perform. It will get to know that it has to move the data, or it has to copy the data from register B to register A. So if the operand is in the general purpose register of the microprocessor, execution is immediately performed. The time taken in decoding and executing will be of 1 clock cycle. So all total for 1 byte instruction, the total execution of this instruction will take 4 clock cycles, that is 3 clock cycles for fetch cycle and 1 clock cycle for decode and execution purpose. But if an instruction contains data or operand address which are still in the memory, so let's take this example. As I've told you, MVIB05H, this is the opcode. So in fetch cycle, what will happen? Microprocessor will fetch the opcode from the memory and will store it in the its instruction register. There the fetch cycle will get completed. It will take 3 clock cycles. Now what happens, from the instruction register, that opcode will go to the decoder and the instruction will get decoded, and microprocessor will get to know that it has to store some data into the register B, but it does not have this data. It has to receive, or it has to take that data from the memory. So again it has to access the memory. So this is the case when an instruction contains any data or operand which are still in the memory. The CPU has to perform some read operations to get the desired data. So after receiving the data, it performs execute operation. A read cycle is similar to a fetch cycle. In case of a read cycle, the quantity received from the memory are data or operand address instead of an opcode. So for therefore concluding, that is for 1 byte instruction, maximum for 1 byte instruction, what happens, it gets completed in 4 clock cycles, that is 3 clock cycles for fetch cycle and 1 clock cycle for decoding and executing of the instruction. Whereas if the instruction is of 2 or 3 bytes, then what happens, it will take 3 clock cycles for fetch cycle, but more number of clock cycles for execute cycle, which will depend upon the byte of the instruction. So I'll come up with more examples in my next lecture. So I'm ending this class here.